Welcome to speak, Silas. You might have to unmute. We'd love to hear from you. Um, there's a chat channel as well, Silas. We can chat to each other.
I think it could have been accidental or something.
Okay, maybe we'll do that later. We can. Simon, did you have your hand up?
He wrote in the chat.
Ah, oh yeah, greeting. Oh, Silas, yeah. Yes, you are. You're very welcome, Silas. You are here with us, and I'm going to start the session in 2 minutes. Um, just a reminder, that I do record these sessions, and it will be posted on YouTube. So that it's a resource for us to return back to, and obviously for other people to share. People are watching us in different time zones, and so not everyone is able to attend live. Hello to Shanaz, who is flying home from India right now. Well, we've lost Stella as well. So anyway, people come and go. I hope people. Yeah. So firstly, to welcome Silas Muambegu. If I hope I'm saying that right. Greetings to you, Silas, from Mombasa. I understand, and also part of an interesting farmer support group. And we'd love to hear something from you later on. So, not to put you on the spot now, but when you're ready, we're going to love to hear more about your organization. So, welcome to not quite on time. Anyway, welcome to part 6 of the Sector 39 Permaculture Design course. We've tried to do it this way to make this content as available as possible to many different people. As the course progresses, we're going to hear a lot more from you, from seeing images and hearing stories about what you're doing in your communities, the challenges you're facing, how you're using permaculture ethics, principles, techniques, design tools to to face those challenges. And we just to bring people together, is permaculture is a pattern language, and it's a way of thinking, and it's quite a methodical way of thinking, and it leads us to design so that we are creating things with intention. There's many different people. Permaculture's been around since the 1970s. The word was coined by two writers and teachers in the 1970s, actually in Australia. But as a concept, it's bounced around the world. Many people have been playing with it now. 30, 40 years of history, and the threads that kind of bind it together, permaculture, is really the core ideas as articulated by Bill Mollison in his Permaculture Designer's Manual, the book over on my shoulder there. And a few years later, David Holmgren, the co-author, came up with his book, Principles and Pathways Beyond Sustainability. And he gave us permaculture as 3 ethics, 12 principles, and a set of design tools. And I really like David's 12 principles. And for me, it's like the hours of a clock or the months of the season. And you can imagine how these 12 principles kind of flow into a continuous cycle. And so that's very much how I like to it helps me order my thoughts. And also as a teacher, it helps me think about the sequence of how to put my training sessions together and how to to think about these sessions and sort of help me remember where we're at, if you like, in the narrative. So principle 12, sort of midnight, midday, the start of the cycle is about change and the inevitability of change. And it also tells us, though, is that because change is inevitable and nature's constantly in motion, is there are constantly new opportunities. And there are flows of energy that maybe come at different times and in different places, but that we can tap into to if you like, to fuel our designs. So change can be scary, change can be difficult, but change also creates opportunities. How do we navigate ourselves through change? Well, we observe and interact. We use our eyes and ears. We use our intellect, ask questions. We look around to see what resources are, what are the challenges, what things are working, what things aren't working so well, what changes could we make, what information do we need to improve. So we say we move from this cycle of change to observe and interact. Our first objective, and this is what we've been talking about on the PDC so far, when we observe nature, when we allow nature to be our teacher, when we allow nature to inform us, what we see is going on around us is summarized by the statement, catch and store energy. David Holmgren reminds us that the only new energy coming into the system is the energy from the sun. And nature organizes itself, photosynthesis, plants, surface area, to trap that energy and to channel it, turn it into sugars and carbohydrates. And then plants use these stored forms of energy to manipulate, influence, interact with all the other species around, which maintain the right environment for the plants, for the trees. Plants catch and store energy for the purposes of obtaining a yield. And that yield is more tree, more leaves, more seeds, more nuts, the food that feeds the soil microbes and the soil fungi. These are yields. And we've been thinking about these as processes. So we say that the third principle is obtain a yield. We're reminded you can't work on an empty stomach. We have to feed ourselves and then also make sure every element in the system is fed for that system to be able to go on and be successful. So in this session, I thought let's think a little bit more deeply about the nature of yields and what they are, and then also strategies to maximize yields. So I'm going to start with that, and I'm going to start thinking about plants and growing systems, and thinking about our strategies to maximize yields. Okay. We welcome questions and comments. Otherwise, we just tick along. How we go. Okay, and if you're not contributing, we're welcome to contribute, but if you are not, then try and keep your microphone off so we don't get random noises. Okay. As permaculture designers, we aim to maximize the return from each resource. We're trying to use design thinking so that we do the minimum amount of work. We do the minimum input required that creates the maximum output. If we're doing a task, whatever that task is, and it's laborious and heavy and the return is very small, we're probably doing it wrong. Permaculture kind of teaches us that, hard work is a symptom of bad design. If we're throwing resources, we're throwing money at solving a problem, we're not really solving the problem, we're kind of feeding it. So maximizing the return from every resource. Anyway, there's a lot of examples of this. I'm going to jump around into it, but I'm going to start thinking about growing strategies. And we can apply this thinking to anything, but many of us are, if not farmers, we're gardeners or we're small scale growers, and that represents quite a lot of work. It represents materials and effort that we're putting into it, and we want to get the maximum return. And permaculture really helps us to do that and to think about how we organize things strategically so we get multiple benefits, because we're interested in linked together integrated systems, because we're allowing nature to be our teacher. Nature doesn't give us monocultures. Nature gives us polycultures. Nature doesn't just group together annual plants. It mixes together plants that live a long time, plants that live a medium time, plants that live a short time. We mix nature. These are lessons we get when we observe nature. Okay, I'm kind of paraphrasing and trying to summarize because I'm aware we have some kind of latecomers, but I do encourage you to go back and look at the early lectures, and there's also resources to download from the Academy website. Again, links are placed around. So let's start from the whole beginning, and I guess we're just coming into the new growing season here in the UK. So here we are, it's February the 7th, it's cold outside, it's frost on the ground. A few perennial plants have already started to germinate and come back, but seeds, too cold for seeds to start germinating. So we're at the beginning of the cycle. So let's just think about strategies to maximize yields. Well, the whole growing process, especially with our, certainly with our annuals and our vegetables, begins with the seeds. Seeds can be expensive, they can be hard to get hold of. Our choice of seeds and our choice of the variety of the plant that we are going to grow, the variety of that particular plant, can make every difference to the quality of our eventual outcome. So it's worth paying attention to every detailed part of the whole process. Now, where we don't have choice or we have very limited choice, we might have to go with just what's available. But think about seeds that are produced commercially at the F1 hybrids, crossbreds, seeds, the plants that you can't save the seed from are grown for a particular set of reasons. And they can have new varieties, they can be disease resistant and strong growing, but maybe they don't satisfy other potentials like saving seed for future generations. So actually, to begin to think a bit more about our own seed saving, the first lesson to learn is that actually some types of plant are much easier to save than others. And what's always good in permaculture, what we suggest is start with the easy ones. So tomato seeds are quite good to save. We could go into this, and beans and peas are quite good to save, but maybe we should go into this a bit more detail further on. But let's just keep thinking. Our choice of variety of seed. So we, by seed saving and by being selective about the variety of seed that we're growing, we might be growing types of plants that are suited to where we are, suited to our soil types, soil conditions, and obviously our sort of local climate. So these are all considerations. Organic seeds, more the type that you saved yourself, more the type that are locally adjusted, also tend to not all all ripen at the same time. They have a much longer ripening period. And for small farmers and gardeners, that's really useful because we don't necessarily want all of our produce on the same day. Whereas commercial growers, that's a very, very big consideration for them. They want all of their tomatoes or their onions to be ready at the same time so they can harvest, crop, and take to market. So right from the beginning of the whole growing process, you realize there's choices involved, there's plans, there's strategy. The types of seeds that we're selecting and the varieties and the source of where they've come from, all of that might affect the long-term sort of trajectory of our growing plan. Maybe it's just worth mentioning right at the beginning as well is that when a seed first germinates and that first little shoot comes out, that's really when it's at its most vulnerable. Changing too wet or too dry, it's going to die. An insect or a pest comes along, a small, disturbs it even a little bit, and it can die. So once we've thought about the seeds and the variety and where they've come from and the characteristics of that seed, we might want to work to put it. First strategy might be to create a seed bed. Let's create the ideal conditions for that seed to germinate and where I can keep an eye on it. So I'm going to have my seed bed close to my house in my zone 1, because then I can keep an eye on it and see when it needs watering, and I can protect it from being attacked perhaps by insects or birds or any other potential threat. And then I can then think about, once the plants are germinating, about transplanting them into a dedicated place where they're then going to grow. It's worth mentioning, some types of plants are very happy being transplanted. They don't mind. And other kinds of plants, actually, it really knocks them back and disturbs them and stresses them. And generally, it's the root crops. It's the plants with a deep taproot that don't like to be moved. So this is all informing our strategy about how we maximize our yields. We choose the right kinds of seeds, we germinate them in their ideal conditions, and then we create the right kind of nursery bed or growing on bed for the types of plants that we're creating, whether they're fast growing herbaceous plants like vegetables, or whether they're long-term plants growing like trees. So strategies to maximize yield. We just need to be a little bit thoughtful. These are terms which we will use again and again and again or throughout the PDC. And when we go and look at different examples, and we see the work of what's going on in different places, we might use these words to describe what we're seeing. So growing strategies, we've thought about our seeds and germinating them and then getting them ready. So we might prepare raised beds. We might create dedicated areas for growing our plants. And we might do this in a very strategic way. For example, by removing the soil from paths and then piling up into the bed, we're doubling the depth of the A horizon. We're concentrating on creating the right conditions to favor the plants that we're growing. And if we're growing vegetables, then we want an open, aerated, fertile, moist soil. And we want a good depth of it. At least, if we have 30 centimeters, then we can grow anything we want in that. And we do that by building raised beds and building the soil up on top, and then protecting that soil all the time with a mulch being a cover of dead plant matter. That plant matter that's slowly breaking down, holding moisture at the surface of the soil, and obviously slowly releasing nutrients to the soil microbes and maintain the right conditions for your plants to grow. Part of our growing strategy might be no dig, or the next one, minimum tillage. It's not always possible to grow plants all the time with the no dig, especially root crops. But what we learned when we looked at under the heading of catch and store energy, we begin to understand that soil is a huge store of energy, and we're interacting with that store of energy to grow our plants. So we don't want to disturb the soil any more than we have to do the cultivation. So again, when we make dedicated raised beds, we're moved around, but we're not going to do it again. And then we're going to keep it mulched and protected. We're going to either mulch it with dead material, or we're going to use green manures. We're going to use sometimes you might call them cover crops. Green manure cover crops are plants that we grow to feed the soil and to protect the soil. We can think about the microclimate around our beds. The shade, can we construct a shade to reduce evaporation, increase water retention? Using our observe and interact, let's be really conscious of how hot and dry the environment is that we're growing, and understand that the harsher, the more exposed, we need to create shelter. So our design of our raised beds and the shading on our raised beds will be informed by the conditions that we're growing in. Observe and interact, catch and store energy, obtain a yield. There are strategies for wicking beds that will use the fact that water will wick through certain materials to maintain humidity. And obviously, we've touched already on swales, larger landscape systems that channel surface water to catch it, slow it down, and make it sink in. With compost making, we're going to talk about compost a lot going forward. We're going to try and today as well, I'm going to understand a little bit more about compost and compost making. We'll begin to touch on biochar as a strategy and using biochar as an addition to your soils. And we'll talk about water catchment and with roofs and tanks. And I think we touched on that a little bit as well. But as I repeat certain things again and again, is the easiest and cheapest place to store water is in the soil. And you only really need to store water above the ground, so perhaps for nursery beds and for drinking water. So the water we store above ground is of immensely higher value because we can obviously use gravity to flow it. The water that's in the soil, we need it to stay there so it can nourish plants. And we do that by keeping the soil and keeping it mulched, keeping living plants there. So these are growing strategies. These are all, begin to think about how all of this kind of thinking might come together to be able to improve our outputs, to be able to build systems are much more resilient than the ones we're currently working on. So think about permaculture as this journey, these 12 steps of thinking. I think how these ideas now begin to kind of jostle to create a greater whole. I'm going to show you some examples of these as well later on today. So don't worry too much, but I want you to become familiar with these terms. And when we talk about them, we can, we really understand why they're so important. These are really important, central to our strategies. This is what we're trying to constantly increase and constantly improve on in our growing systems. I saw this nice graphic today. A friend of mine, Anna Locke, if you're listening, Anna, shared this 5 top tips for choose. And I thought about fruit trees. I thought about how in our gardens and growing systems and fields and field edges, how we might want to stack in different types of yield. And that sometimes the presence of different kinds of plants add to the total yield. Trees provide a bit of shade. Trees can provide, mulch and other nutrient cycling, feeding other insects and birds that are part of the nutrient cycle. So let's think about integrating trees into systems. Here's a few top tips for maximizing the yield from your fruit trees. Spend some time thinking about what you would like to eat or make. There's no point in growing stuff that you don't want to harvest. Explore all the beautiful varieties of the fruit you would like, especially heritage and local varieties. Now, Paul Agola there in Kenya, he's just been doing a lot of mango tree propagating. He's been doing grafting and using that as a tool to share quality material across his community and to boost, obviously, to create a large yield of mangoes. Choose the right size of tree for your space, small, medium, or large rootstocks. Okay, we can talk about this a little bit more later on. There's two kinds of fruit trees, essentially. There are ones grown on their own root, just grown from the pip or the stone. And then there are ones which have been grafted. And grafting is a technique which allows us to set the final size of the tree and also the variety of fruit. So that's an interesting thing. We'll talk about that a bit more. So this is more of a Western top tip. But rather than buying established fruit trees in pots, if you buy them in the winter when they're dormant, you can move them bare rooted, and they're a lot cheaper. And the fifth tip is maximizing yield by shaping the tree, exploring how the shape of the tree can be set by pruning and by training branches so that it captures and stores the maximum amount of the sun's energy and provides the most amount of fruit. So there's techniques, there's details about how we can maximize the yield on fruit trees by understanding how they grow, the shape, the varieties, the timing, when to move them and to plant them, and to think about the varieties that we actually want to use ourselves or might have the highest value in our local market or community. So it's like a checklist, thinking about how we maximize yields. Okay, look, I put in a little picture here. This is an apple tree, but this could be a mango tree if you're in the tropics. This could be, and let's just have a quick look at here. So this part of the tree here is what we call as the rootstock. That has come from one source, from one plant, and these two pieces of wood here we call the scion. That wood, that variety of plant, have been selected for the fruit. So the rootstock sets the vigor of the tree. By vigor, we mean how fast and how big it's going to grow. The more vigorous, the bigger the tree. The bigger the tree, the more we can't reach the fruit, and they go up high in the sky. The further apart we need to space the trees to allow that space. If we have a smaller rootstock, a dwarfing rootstock, the tree grows with less vigor. So it's smaller, it's easier to manage, there's less pruning, we can reach the fruit more, but the tree's more vulnerable. You might need to stake it, you might need to feed it, you might need to spend more time looking after the tree. So there's a trade-off between the dwarfing or semi-dwarfing rootstock varieties and the really vigorous, fast-growing ones, or the on their own roots, sort of vigorous wild kinds of trees. So the advantages why we might graft trees is I can select, these could actually be two different varieties of apples. I could have a red one and a yellow one on the same tree if I wanted. Suddenly there's a whole new set of possibilities. I might even change what the tree is growing because the market conditions might change. Many options as well. And again, there's a lot of detail into the techniques of fruit tree grafting and how we might approach it and what's right at certain times of year. So I've said this before, but permaculture is a study we move from patterns to detail. So before we go into too much detail of the different kinds of grafting techniques, firstly, we're just thinking about why we would do grafting, what would be the advantages, what's the kind of the downside of it. And talking to Paul, he had propagated his own rootstocks for the mango trees, but the scion wood, this bit, the bit that they're adding, that's going to be the yield, the fruits, those were quite expensive. He can remind me how much they were, but I don't know, $1 or $2 each or something like that. So, we might get a better tree, better fruit, more controlled growing conditions, but it's going to cost us money. So these are all elements that we'll have to consider in our design process and what our priorities are in terms of, what are our budgets and is it worthwhile giving up space to grow a poor tree, or this is why we use permaculture design, try and think these things through. So I think another thing which is going to come around a lot in our discussions about maximizing yields, about how we use permaculture design, also the idea about how we combine things. So I already said that permaculture does, excuse me, in permaculture we try to avoid monocultures, because when we look at nature, we never see a strong domination from a single plant. We notice that plants join together and that they can actually act as companions to each other. So you might include non-productive plants in your growing areas, because not that you're going to eat them, but they're going to create the right conditions for the plants that you are, for the plants that you value the most. I'm just going to pause for a second. I've got, just check messages inbound. Okay, that looks all right. I don't know why my phone was ringing. Okay. We want to have a mix of crops. Let's explore patterns, combinations that might work together. Let's understand that some plants actually work as companions to others. If you're growing in a harsh environment, if you can mix together support species with your crop, you'll do much better. There's loads of detail where we can study from, learn from that. Let's think about this idea of polyculture. Poly being many, growing not a monoculture, the opposite, combinations of plants. How can we use trees, perennials, to support our annuals and our cover crops? So think about growing in a sequence as well. The more water we can bring into our system, the more productive it's going to be. Can we produce fish? Can we do aquaponics? Can we have ponds and lakes and containers? Life happens in water. The more water we can have trapped and stored on our site, the more potential for yields there are. Let's not forget that there are trees that fix nitrogen, plants that we can grow again, perhaps as fodder for goats and chickens, and something which is also going to continuously help us build our soils. Maybe we could define field edges with nitrogen fixing plants. This Lucina we've been talking about. It's a plant you can cut and coppice very strongly and it will keep growing back. Can we integrate other elements into our system? Bees, beekeeping, bees are this. The honey is a yield. The bees are much part of any polyculture food system. We mentioned bees. Maybe we could also carefully integrate poultry. I don't know, chickens, ducks, turkeys. You name it. There's always the ability to add elements into the system, into our growing system, so that where they're going to contribute to the whole system. Think about chickens scratch and turn. They can eat rotten fruit. They control insect larvae. They can cause a lot of damage as well in the garden. So just think about how can you use strategies to manage them so that they contribute to the yield. Because if you've got the chickens or ducks doing work for you and you get the yield of the chickens and the eggs, then you're producing more from your system. Now remember, Bill Mollison said to us that the potential yield of a system is unlimited. Maybe the only limitation is your own imagination about how you stack things together. So there's a challenge. I don't know what the answer is. Maybe he's right, maybe he's wrong, but he's definitely pushing us to explore in that way. Whatever you've got, and whatever you're producing, you could add something else. You could have some honey. You could have some fish. You could get another tree in there. How much can you stack into? We can use vines. We can explore the surfaces of buildings and so forth. Strategies to improve yields. That's what we're thinking about. I also think we're going to have to think, we need to invest time into thinking about people and team building, how we work with other people, how we motivate people to work together. Can we create a common vision? Can we act and feel like a team? Because really, the resources, the potentials are always around us. We might not always realize it. It might take some time to assemble those and start the process, but for sure they're there. The challenge really is galvanizing the people, the vision, and creating the flow so that people feel that they're working together. So strategies to increase yields, we're going to need to think about people and team building. We're going to need more skills in these areas. And I think permaculture offers a lot to us in these areas. So think about how permaculture as an ethos. Permaculture has these ethics within it, and that's very deliberately, because if we can come and agree about earth care, people care, fair share, understand we're all trying to meet our needs, but we're not in competition. If we collaborate through community and we collaborate through an understanding of the natural world, this is the way to bring us together. So we can build teams, we can come together as groups by offering training in permaculture, training in the specific skills that sit within permaculture, making compost, harvesting water, looking after plants, looking after animals. It's many different. We can create tasks that encourage us to work in teams. Teamwork brings people together. Teamwork creates consistency. Many hands Many hands make light work. Some tasks, if you just got to do it by yourself, it's just soul destroying and backbreaking. If you have a bunch of people to help, it can be done in a fraction of the time, and then you can go on and help other people. So teamwork. Think about savings and loan schemes, groups of, if you're pioneers, farmers, if you're in a refugee settlement, you're there's some people are trying to start their permaculture entering very challenging circumstances and maybe with very little resource. So how can we work together and pull as a team And what little funds that we do have, can we use them strategically? Can we save them, buy the seeds, the tools, the things actually going to create yields we can sell, and then reinvest that money. Just think about that. And the things obviously that we need is the seeds, the training, the workwear, tools, gloves, boots, all of those things. So yeah, in our approaching our design, we're trying to meet the needs of every part of the system. So if we're working with people, we have to think about the needs of those people too, the tools they need, the clothing they need, the knowledge they need, and the feeling of teamship, to feel empowered, to work together towards these longer term goals. If we can bring people together, there's nothing that we can't achieve. And I think this is one of the most powerful things that permaculture has to offer. So let's really understand that we need to go down deeper on all of these lines of thinking. And as we get deeper into the PDC, we're going to be going deeper down on some of these things, the skills with that we need, and understanding that goes with that. Okay. Thinking about how we approach growing plants and food, thinking about using permaculture to inform this process, thinking about how we are learning from nature. Okay. Everyone who's growing or farming immediately talks about pests and pesticides. And how do we control pests? What can we use to, and within that, it's almost the idea that in growing, we're kind of going to war, that there are goodies and baddies. That our plants, our yield is the goodie, and anything that might be eating it or, coming at it is the baddie. Well, maybe that's not exactly the case. Maybe it's a little bit more complicated than that. And in permaculture, I'm going to kind of dare you to think really that, I don't know, I'm not going to give any absolutes, but let's try and not use the words weed and pest. Or when we do use the word weed and pest, let's think about what we mean by that. Because really, a weed is a plant in the wrong place, or it's an unintended consequence. It's not necessarily your enemy. And a pest, again, it might be telling you something. The presence of that pest might be telling you that your plant isn't healthy. It might be actually giving you information and saying you need to make changes to your system. And rather than seeing the pest or the weed and going, I'm going to war, I'm going to, throw poisons at you, or I'm going to, put a lot of energy into getting rid of you, is maybe you haven't created the right conditions for the plants that you're trying to grow. So let's dare to think about that slightly differently. So let's say the first thing is healthy, strong plants don't get attacked by pests. Hey, how about that? It's the weak plants that get attacked. When a plant is healthy and strong, and the density of the sap in the plant becomes richer, becomes more nutrient dense, and actually beyond a certain level, most insects can't eat that. They can't digest it. It's poisonous to them. So how we might approach the health of our garden, how we might approach this idea of, managing pest attack, managing the vulnerability of our plants is good to know. First, straight off, is if we've got healthy plants, we've chosen the right seeds, we've created the right growing conditions, then we won't get pests, and we've mixed them together in a nice polyculture, we won't get pests. If It's in a good, moist, open soil, an aerobic soil with moisture and with a healthy soil biota. That plant will be healthy. That plant will be able to resist pest attack. If we think about beneficial plant associations, that we can mix plants together, we make it much harder for the pests to find their target plant. So here's the thing. Insects aren't that clever. They're fairly simple things, and they're attracted, if they're looking for their target plant, attracted usually by the color, smell, the texture, and to a degree the shape. They're simple triggers that are encouraging insects. And again, a really healthy plant, there is nowhere for that insect to latch on. It's going to get killed if it tries to eat a really healthy plant. So beneficial plant associations. So if you're growing a plant which you know is a little bit vulnerable to certain kind of pest, mix it up with another plant that's a different color. Or use plants that have stronger colors, like calendula, like marigolds, nasturtiums we use a lot. Plants that have a smell, like tansy, other herb plants, using onions and garlic along border edges confuses pests because they're strong smelling. Allow some of the plants in your garden also to go through their full cycle. Allow them to go to seed, allow them to express themselves, to create biomass, because that also creates habitat for the things that predate on the pests. So our simple strategy for integrated pest management is create a really healthy plant, create an environment that's confusing and difficult for potential pests, and then also enhance the conditions that support the predator. If you've got lizards or birds regularly visiting your garden, they'll eat a lot of the insects. Think about how you use chickens or how you might allow wild other animals to interact with your garden to help regulate the potential pest species. It's only a pest because it's been allowed to multiply. In a small number, it's not a pest, it's just part of the ecosystem. When you start using the word pest or weed, something's out of balance. And if you can return that balance, that problematic species will go away. So these are the kind of founding principles behind what we call integrated pest management. All we're doing is copying nature. All we're doing is applying the patterns that we see in nature to our designed systems, gardens, field edges, main crops, wherever, whatever it is that we're designing. So there's a kind of a cycle in integrated pest management is observe and interact. Inspection. Get down on your knees. Look underneath the plants. Look inside the the crooks, necks, and crannies, and underneath the leaves. Learn to look in an inquisitive way. What am I seeing? If there's damage on the leaf, ask yourself why. What was the source of that? So can we? Let's try and identify what we see. If we don't know what the cause is or what the problem is, we can describe it. Ask ourselves, do we think that what we're seeing, is that insect attack, or is that a disease? Is that a nutrient deficiency? We can monitor, we can take notes, we can be conscious of how concerned should I be for what I'm seeing? Do I need to take action? What action will I take? There's like a hierarchy of actions in integrated pest management. So we'll look at that next, but and then has the action that I've taken, I squished a few eggs. First, here we go. I'm inspecting my plant. I identify, oh, look, I've got larvae growing underneath the leaves. I'm going to identify what I think those are. My action is I'm just going to squish those eggs with my fingers, and then I'm going to come back the next day and go, did that work? Was that enough? Are there lots more? Is that all I need to do? Maybe I need to do more than that. I'm going to evaluate, and off we go. Carry on inspecting, carry on asking those very simple questions. But if we're not observing, and the secret with these, so think about pest attack. It's telling you something about your garden, your plant, your something, your field, that something's out of balance. You're saying your plants are vulnerable; they could be healthier, and then what interventions can I make that's going to restore the long term? So try and resolve that problem in the long term, and so it doesn't keep happening, and also in the short term. Integrated pest management. So think of that as a constant cycle of observe and interact, learning. Why am I getting this particular thing? What is that telling me about the health of the system itself? So we're touching on that. This is really touching on session 4, really, when we start thinking about systems, step by step. So there's a hierarchy of responses, and let's say the bottom level of this pyramid, the most important part is prevention. Let's not have any problems at all. Let's do that by having the right plants in healthy soils with the right level of moisture, and we've thought about the balance of nutrients available in the soil. If we've got a healthy plant in a healthy soil, we shouldn't be having problems. Our next level is to stop if there is a problem, is make interventions very early on, because these potential pest populations can multiply very quickly. So if we find a few eggs early on and squish them, we're preventing them from that generation going on and having babies who have babies who have babies. We can weed carefully. We can. It's encouraging us to. I was talking about mowing and height of mowing as well. I guess that's controlling grass, but we weed, we observe, we make small interactions. We can make small traps. We can make interventions, squishing things and collecting things and picking them off at a certain level. When we get on a bigger scale and maybe more a wider pest attack, then we're thinking about encouraging the predators of the pest, of the target species. Maybe the reason why we have a lot of greenfly is because we don't have enough ladybirds. We don't have enough lacewings and hoverflies. If we can then enhance the conditions for predators, encourage them into the garden, sometimes you can actually breed or buy in predator species, which you can then add to, or even disease-causing organisms. There's a nematode that attacks the slug. You can buy a preparation with that and water that into your garden. But really, the question you should be asking is if you're having a slug attack or snail attack or mite attack, is why is that happening? And ultimately, the answer to resolve that comes from the lower levels of this pyramid. Is we need to create the right conditions for the plant so it's not stressed, then we won't have a problem. Now, the fourth level and the ultimate, thing, the last thing, the most extreme thing that we might do would be to come in with a pesticide. Now, I would always think very carefully about that. we can create organic pesticides. We can create biodegradable, non-toxic pesticides out of natural ingredients. So, and a lot of those work by choking the airwaves of the pest insects. So sprays with, sticky, flowery type material, making like a glue, things which are caustic or burn to the insects. And there's a set of strategies around that. But I'd stress, multiple times really. One is we don't want to use any kind of pesticide that's going to affect the soil microbes, because that's going to affect the long-term fertility of your soil, and then that's going to actually erode the base of your IPM triangle. It's more important to concentrate on the health of the soil than by attacking the things that are actually telling you that your soil isn't healthy. You're not solving the problem by killing the pest. You're actually shooting the messenger. It's a very, very important lesson. So using pesticides would be a single application, one time only, non-toxic, to save a situation that then is then going to inform you, to save your crop, to then inform you perhaps to move on, to work at lower levels of this pyramid. Spend more time thinking about your soil quality, your compost, and all of the other elements of your system. Integrated pest management. This is permaculture's trying to give us patterns to help us order our thoughts in a sort of strategic and priority way. This is a quote from Ali Raza. Soil. A nation that destroys its soil destroys itself. It's a very big statement. If the only new energy coming in is coming from the sun, and only plants can translate that energy into storable, digestible food, and plants grow in soil, we need soil. Soil's the most important thing. Soil's that magic place where dead stuff becomes alive stuff again. So we have to, very much within our strategies to increase yields, is, hey, we're super interested in soil. We're really interested in maintaining the quality of our soil. So we've already touched on soil in an earlier lecture, and in that lecture we talked about the soil food web. Now I want to go deeper on that now, and this is going to be the beginning of our understanding of how we get rid of pests. This is the beginning of our understanding of how we make a soil that can catch and store enormous amounts of water and have vast root systems that can access that water. We can make your growing systems much more drought proof by teaming up with the soil food web. So this is the beginning now of thinking a bit more deeply about how we create the optimum conditions to grow plants. Plants that translate the energy of the sun into the materials that we need for our clothes, for our shelter, for our energy, and for our food. This is very, very important. And again, permaculture, patterns to detail. We keep coming around. I want you to see the patterns. By now, you should be recognizing these patterns. We're going to be adding layer on layer on layer of detail, because when we talk about soil science, there's no bottom. There's no, it just gets more and more fantastical. It gets more and more complex. It's a wild ride as a subject. But let's not get far ahead of ourselves. Quick revision. Trophic levels. Trophic relating to energy translation. So the energy coming in is from the sun, and that is translated by plants into organic matter. So in terms of biomass in any system, there's going to be the most biomass is going to be at the first trophic level, because as things eat that biomass and turn it into fungi, nematodes, and bacteria, some of that energy is going to be lost. So that because there's obviously organisms respire and that energy dissipates. So the biomass in an ecosystem is always going to be sort of pyramidal in structure, and that's an important way of thinking about our the trophic layers within soil. And there's 5. And to have healthy soil that's totally resistant to pest attack, you need all 5. There's no mix and match here. We have to build the whole ecosystem. And let's just remind us what they look like. There are root-feeding nematodes. They're little worms. They're not really the good guys. They are taking energy away from plants, but they also might be eaten by microarthropods, little insects, and those nutrients then become available to the system again. There are enormous quantities of bacteria and fungi that build associations with the roots. So a teaspoon in soil might have thousands of different types of bacteria in it. It might have several miles of fungi in it. And as those organisms live and die, they're living off the sugars and exudates coming off the roots of the plants. They're often returning, they're maybe decomposing. They have a relationship with the plants where their nutrients are constantly, energy's coming from the plants to these organisms, and organisms are making plant available nutrients returning back to the plant. So as we move up this trophic pyramid, as we get through into the soil food web, we realize that there are protozoa, nematodes, arthropods that predate on the fungi and bacteria. Fungal and bacterial feeding nematodes. Little insects that break up and shred organic matter, that then is digested by fungi, bacteria, and returned back to plants again. The more of these individual organisms that we have, and the greater numbers of them that we have, the healthier your soil is. So in our strategies to increase our yields, we're going to be teaming up with the soil food web. We're going to be becoming more familiar with the idea of bacteria, fungi, nematodes, microarthropods, protozoa, and the larger worms, nematodes, arthropods, and the birds and mammals that feed on them. These are the nutrients of your soil, and these make the nutrients bioavailable to your plants. Okay. I want to just bring you into. I'm going to name check a couple of things now. Okay, sorry. This is something that I've been reading more about recently and beginning to understand, which is something I hadn't fully understood, is the minerals that you need to grow your plants are in your soil. They're in the clay, silt, sands, pebbles, and rocks. Everything you need is there. The raw materials are there. I don't care what type of soil you've got. The potential minerals that plants need are there. But the thing is, they're not bioavailable. Plants can't access them. As you build your soil food web, as the life, the biota in the soil lives and dies, those nutrients then start to cycle and they start to become available. And the more available they are, the healthier your plants are. And what's interesting is your plants become more nutritious. And By nutritious, I mean they contain more sugar, more vitamins, and more minerals. And we can think about the nutrient density of the sap of a plant. So you think if a plant is really healthy because it's supported by all of this life in the soil, then the nutrients, the juice in these leaves are going to be higher quality. How do we know? Well, one way to know is taste, actually. The stronger the taste, the nicer, the better tasting the plant, the vegetable you might be familiar with, that's giving a clue that it's going to have more nutrients in it, in its leaves. So this little tool here, this eye, it's a light, it's called a refractometer. It's a little tool. I have showed some of my students it, and yeah, it's a very simple tool that you squeeze your plant and you need to extract the sap, not the mush, not the fibers of the plant, but the sap, the liquid. And you put a drop of it on this slide and close the lid, and then you hold it to the light. And when you look down it, you can see a scale. This is what this other image is of. And on that scale, there'll be a line, and you can read that value. And that value is telling you the bricks value of the sap of that plant. And what that means is it's telling you how much dissolved sugar there is in it. And the higher that bricks value, the denser, the more syrupy the sap of the plant is. And that's telling you that that plant is really healthy and that it's nutrient dense. And therefore, the healthier the plant, the more certain we are that we have the correct soil biology in place, because that's the only way that plant is going to have a high bricks value. It's called a BRIX refractometer, and with a brick scale, it's telling us how syrupy the sap of the plant is. So we'll talk about this a bit more in detail later on, but once it gets above 8, 9, 10, 11, 12% sugars in the sap, then the aphids and stem-boring plant insects can't access it anymore. It kills them. And as it rises, then it becomes resistant to more and more different types of potential pest attack. So very, very interesting, and something that we will go into a bit later on. We've been doing some research into this over the last couple of years, and something which I want to share with you. But really what we're understanding is to have a resilient, productive, growing system, we need to build a relationship with the whole of this soil food web. I'm going to name check Dr. Elaine Ingram and her team. She's a soil scientist. She's been studying soils for like 3 decades. And it's really, when I was at school, when I was at college, when I was at university, we used to say, professors and teachers would say, oh, the soil is so, what's going on in that top inch or two of soil is so complex, we don't understand it. And for a long time, that's very true. And to a certain extent, we don't need to know the name of all these insects. We don't need to actually identify every bacteria. What we need to do is to understand the pattern. We need to understand the conditions that soil life needs so that it can get on with the job it needs to do. But it's Dr. Elaine Ingram and her team who have really unpacked soil biology, who have really begun to understand what is going on and to use microscopes and tools to identify and name these elements, understanding different forms of bacteria, fungi, nematodes, protozoa, microarthropods, and everything else in the system, how they contribute and how who are the goodies and who are the baddies, or what conditions, what processes do we need to create the right conditions so that we have the soil goodies, the beneficial ones, the things we want to promote, the ones that we want, and we want to suppress the ones that are damaging. So here's So you can join in on Dr. Elaine Ingram's Soil Food Web. There are lectures and you can do a whole program and pay for, but there's lots of free content on YouTube, and I've summarized some of her work on a blog post on the Sector 39 website as well. But I'll give you a few of her pearls of wisdom. There is no soil on this planet that does not contain the nutrients to grow your plants. What we have done, the reason why your plants aren't growing is because we've killed the soil biology. If you kill the soil biology, then you have to do the work that they were doing. So if you haven't got the worms and the microbes and the bacteria and fungi in your soil that maintains that soil, then you've got to do it. You've got to buy additives and add them. You've got to add the water. You've got to make the compost. It's hard work. So if we understand this complex web of life in the soil, if we can work with that and promote them, create the right conditions for them so that we get the right kinds of soil organisms, then our plants are healthy and the soil is healthy and the nutrients are continuously available. We do not need to buy fertilizers, and we do not need to buy pesticides. We need to rebuild the soil. And in rebuilding the soil and identifying that that's one of our key roles and objectives in permaculture, then that helps us understand that we are a team, that we're doing this together. The whole work, the way we solve this big, scary, huge climate problem is everybody needs to go home and build soil, starting right from their back garden, right from their back door of their house. And, closer to home, we pay more attention, we get more feedback, we'll get more motivation. We need to start building, catching and storing energy and building systems together, and understand that as a global endeavor will make a very significant change, whilst, looking after us. So you can make compost out of anything. All waste materials, all organically sourced waste materials, something that has lived and can compost. All organic matter in the right conditions will break down into compost. It's a kind of a universal truth. So we can think about farm wastes, think about house wastes, think about where they've come from, and whether they're hazardous or not. We might need different plans and strategies to deal with these things, but they all are potentially useful to us. It is even, and we talk about manures and the farm waste, but there's also human manure. Again, we have to be careful. There might be pathogens, could be disease-causing organisms, parasites. But at the end of the day, it's the same nutrients and materials that the soil is made out of and the plants are cycling. So it's about handling and using things appropriately. Our weeds can go into our compost, but we might be aware that those weeds might be carrying seeds. We might be accidentally promoting plants that otherwise we might regard to be pests. But again, if we handle those in the right way, they're part of the yield of the system and they can be returned and composted and reincorporated. Think about all those dry grasses, how much of that might get burned off every year. Think about the potential value of that carbon, the straw and the stems that could be used for composting. Think about how we can use those as mulches or incorporate them into systems that are going to help build soil carbon. Dr. Elaine Ingrams tells us that to have really healthy soil, you need to get it up to about 3% organic matter. And the way to do that is to add carbon, add compost, use mulch. In a small and localized area, that's fine. We can do that. If we're doing it on a larger area, we might need to think again. We might need different strategies. because we can't, making tons and tons of compost and then carrying it and distributing it, that becomes very challenging. Again, one of our key ideas in permaculture is we start small, we learn the lesson, and then as we scale up, we want to make mistakes at a small scale. A small scale mistake is a learning opportunity. A large scale mistake is a disaster. So let's think about all waste materials and the source of where it comes from and a strategy in which we might be able to collect it and channel it and usefully use it in a compost system. There's two broad types of your waste, and typically we might, although it's not always exclusively true, but talk about greens and browns. I think the things that have more nitrogen in them tend to be the greens. So by that I mean fresh green leaves and grasses and food waste, and actually manures are very high in nitrogen. So the greens tend to be high in nitrogen, and this is the energy. This is the fuel, because in your compost heap, you're trying to create the perfect conditions for a microbe party. You want them to reproduce, replicate, breed, and promote themselves. So, question. Well, okay, why do we make compost? Instead of just going on about compost and how important it is, even why? Well, we're making compost because we want to rebuild the biology. We want to energize the biology in the soil. The minerals you need are there. You don't need fertilizer. What you need is microbes. You need the right microbes to make those nutrients cycle and become bioavailable, become available to plants. It's no good if they're just locked up in the soil. They have to be made available to the plants. And it's the life in the soil that does that. It's the life in the soil that makes that happen. So our first strategy for promoting the life in the soil is to create the ideal conditions for it. And we do that with compost. And in a compost heap, we're bringing together greens and browns. We're bringing together sources of nitrogen and sources of carbon. The carbon is food for the fungi. The nitrogen is energy for the microbes. The microbes are going to have a party, and the fungi are going to have a party, and the whole lot is going to digest that organic matter and feed all of those soil microbes, boost their population, and then make those nutrients bioavailable, plant available nutrients. This is how we do it. And then that instantly, increases the carbon content of your soil, which you want to get to 3%. For long-term fertility. So according to Elaine Ingram's, the greens are about 30-1 carbon to nitrogen. Everything's got a lot of carbon in it because that's what organic matter is made out of. The browns might be 50-1. We bring compost heaps together in layers. Brown, green, brown, green, brown, green. We think about creating the right humidity. It needs to be moist, not wet. It needs to be aerobic. So let's just quickly, I want to just come back to this slide, just to jump forward to the slide, is the organisms that we want to promote, the good guys, those 4 or 5 layers of trophic layers of our trophic pyramid, they're all aerobic. Even those bacteria and fungi at the beginning of the system, just like you and me, if they respire and interact, they produce heat, they breathe in, oxygen and they breathe out carbon dioxide. If you create a low oxygen environment, you're starting to promote the bad guys, the disease-bearing organisms, pathogens, the wrong kind of feeders, things that are going to attack your plant. And we keep our compost heap aerobic by not compacting it, by it not being saturated with water, by having a lot of carbon. The carbon provides, if you like, think of it, creates the structure of the heap. If you just have too much wet stuff, too much green, if you just had a pile of old fruit or something like that, it goes anaerobic. If it's smelly, your compost should smell sweet. If it smells sour, vinegary, stinky, like rotten eggs, you've not done it right. It must not smell. You want it to be aerobic. And in aerobic conditions, we promote the beneficial organisms. So our approach to making a compost heap might be that our consideration is, let's be aware of what's gone in it. If we have human manure in there, if we have weed seeds in there, that's going to contain pathogens. That's going to contain seeds which might be promoting the otherwise species you consider as weeds. So bearing in mind the material that we're composting, bearing in mind the source of that material and what's in it, we might want to create a hot compost heap. And a hot compost heap has certain advantages because it kills the pathogens. So here's really interesting is, as the temperature rises, the first things to die are the disease-causing organisms. Listeria, Salmonella, E. coli, disease-causing organisms are killed by the heat in the compost heap. And if you get your balance of greens and browns right, and your moisture and your oxygen, the heat will quickly rise to 70 degrees centigrade in the middle, where the conditions are optimum. The temperature will rise really quickly. And 70 degrees centigrade, I'll tell you how hot that is. That's when you put your hand into the heap, you can't keep it in. It's just too hot to keep in. Okay, it's 70, that's hot. And what will happen is when you first greens, browns, maybe a bit of soil on top, moisture. If you get that right, the center of your heap will get really hot. It will climb up in temperature and then it will drop down again. That's when you want to turn your heap. And when we say turn it, we don't really mean upside down, we mean inside out. You want to peel off the outer layers and put them into the middle, make a new heap, and then what was in the middle goes on top. You do that a few times. Each time you do it, the temperature will rise again and fall again. And if you've reached 70 degrees centigrade for 48 hours, that's over perhaps a few days, but a total, you can be clear, you can be confident that you've killed any pathogens in that heap, and that what remains is useful, is what you want. So within a compost heap, we raise the temperature, we create the right conditions for the thermophilic bacteria. Bacteria do a lot of breaking down, and then that will kill many of the pathogens and seeds. As the temperature then, as the heap cools down, other organisms will move in, and you'll see worms, compost worms appearing, and other organisms. And they also, as they digest the compost material, they kill the pathogens. So we've got heat treating, and then we've got worm treating. The worms aren't going to kill your weed seeds, but they're going to otherwise create a good, clean compost. We understand source of our materials, create the right conditions, and then we can be confident that we're removing potentially disease-causing organisms and and the potentially a problematic seeds. So, problem organisms favor a low oxygen environment. So, and seeds killed by heat. So we can create an aerobic heat, it will get hot. We can favor the beneficials and we can kill off the problems. So Dr. Elaine has really taken this quite deep. And I'm going to go a little bit into this. And one of the reasons I'm going to go in, well, I think this is hugely important. And I think I feel I'm really learning something by paying attention to her work. This is very contemporary. And I think I can share this with you. And also these are experiments that we're going to be doing in our own garden at Trevlack Farm in later weeks of this course. So we're not just, you'll have a chance to do this yourself and you get a chance to see what us going through these processes. So Dr. Ingram says, Elaine Ingram says, look, if your garden is small or let's say 100 meters, whatever, you can make your compost, you can put it in your wheelbarrow, you can put it on the garden. There we go. And if you put 2 inches, which is what's that, about 6 centimeters a year, that's enough to be able to have your beds be continually fertile. But what happens if you've got 10 acres of garden, or I don't know, a much bigger area to cover? And what happens if you haven't got the physical strength or the material to make tons and tons of compost? What can you do then? Is there another way? And Elaine Ingram says yes. The other way is to make compost tea. So here's now where I invite you onto a journey where we begin to think about something that's new for me, but we will be testing in coming weeks, and I'm excited about this. So here we go, is if we've got a small garden and we've got lots of organic material, we can make compost, we can turn that compost, we can add that as a top dressing to our beds, we continuously feed our garden with this compost. That's great. But once we get to a certain size and we want to address, bigger areas, then perhaps we need other strategies. And the other strategy is to make a compost tea. So we're going to talk about that for a little bit. And then I'm going to jump out of this and we're going to look at some examples from other projects. Okay, so this is a process. This is helping us think about this. So what we're actually going to do is we're going to breed the microbes that we want, the beneficial soil microbes, by creating a really good compost heap. It doesn't have to be huge, but what we want to do is to create the right conditions. And usually to get a good fermentation, get a good reaction, your compost heap needs to be a minimum of 1 meter cubed, or maybe 120 wide and 80 tall or something like that, but approximately 1 meter cube. And we want to have it biodegrading. You just at the ambient temperature. We're not trying to heat it or cool it. We want to have the same conditions as where we will be using it, and we want to make sure we've got a really aerobic heap. So we're going to do that by careful layering and using lots of carbon. To make our compost tea, we're going to make it in water. So this is the thing, is we've got a different strategy here. We can biodegrade lots of organic matter to create the compost organisms and the compost. But if we want to make more, we want to spread it over a much wider area, actually what we need to do is to promote the compost organisms. Can we breed and multiply the compost organisms and then add them to our soil? This is the clever stuff. So, and to do that, we can, well, let's make a tea. You make a tea in water. So our water quality needs to be good. It needs to have the right pH. It needs to be in a sort of ambient temperature. There needs to be energy in that water for the microbes to extract. I'll unpack this. There's quite a lot to think about this here. So I've just been writing this lecture today, so I'm a little bit of fine tuning. So the first thing that we are encouraged to do, so the process of making a compost tea, step one, we make a good compost heap, and at least 1 meter cubed, and we're going to turn it a few times. It's going to go hot, it's going to cool down, we're going to watch all the worms and the visible parts of the soil biota move into that compost heap. It's going to smell nice, it's going to be crumbly and open, and it's not going to be sour or vinegary. We've made a really nice quality, aerobic, nice smelling compost. Okay, so we're now going to make a compost tea. And the first thing that we're going to do is we're going to need a barrel, which we're going to make our tea in, or a container, some kind. And we're going to fill it with water. But the water that we put in that barrel needs to be beneficial for the microbes. So we don't want chlorinated water. Now, if you have Maine's tap water here in the UK, it's got chlorine in it. In fact, it's got other chemicals in it as well, all of which are added to kill life. We don't want loads of microbes in our water pipes. So if our water has it has chlorine and chloramine. Okay, so chlorine will evaporate off as a gas, but chloramine doesn't. It's in the water, and there might be other problems with that, with your water potentially. So all of that is resolved though by adding humic acid, and we are told by Dr. Ingram that if you take some of your compost and put it in a cloth and you run some water through it gently, when that water comes out, it's going to be brown. And that brown color tinge in the water, that's the humic acid. And that contains, it doesn't contain lots of soil microbes, but it contains compounds which will help rectify the water that you're going to use. So the first thing you're going to do is you're going to wash some of your compost through in some kind of sieve or cloth. Wash out some of that humic acid, and you're going to add that to your water, and that will neutralize the chlorine or any other added chemicals. It will make sure that the conditions for the right fermentation are there in the water barrel. So this is how we make a compost tea. We get the water. You'll see us do this, so don't worry about all of the details. I'm trying to walk you through the process. Understand, we're multiplying out those soil microbes. So rather than making tons of compost, we're going to make a tea that promotes at least the first 3 layers of that trophic pyramid, because those organisms have quite a short life cycle. So if we create the right conditions, they will multiply very quickly. So we're going to wash humic acid off of and add that to the barrel, and it's going to, so that there's a slight brown tint to the water. Then we know that we've got enough. It doesn't need to be dark, but just a slight brown tinge to the water from this humic acid, Now we've created the right conditions to promote soil microbes. So the water quality is critical, pH, salt's temperature, and the energy to extract the organisms. All right, yeah, we're going to come to that. We're worried about whether the chlorine or chloramine was in. Okay, so we're now going to, we've created the water with the humic acid. To make our aerated compost tea, we now need to go back to our compost that we've made, and it's good quality. Oh, look, here's a chemical formula. Look at this wonderfully complicated molecule of basically carbon, oxygen, hydrogen, a whole bunch of different things bound together. This is a building block of healthy soil systems. You can buy it, you can preparations of it, but you can produce it yourself by making good compost. Okay, this is how Dr. Ingrams explains it. Now, when we talked about soil and soil formation, I talked about the crumb structure of soil. So, and we also soil particles. Remember clay, silt, sand, gravels, rocks that soils are made out of. And the clay, silt, sand, that's the size of the particle. So clays are really, really small. In fact, about the size of bacteria. But as these soil particles are interacted with by the soil biota, they become glued together into crumbs. So think about this. Imagine that you were trying to empathize my bacteria. Imagine you're a little colony of bacteria, and when it rains, you're going to get washed away. So as these bacteria live and die, what they do is they exude a glue, and they stick themselves to the soil particles. They aggregate the soil particles together and create a crumb structure, which protects them, creates the right conditions, and prevents them from being washed away. So this is the key thing that she really stressed, was to release these microbes into the water of your compost tea. You need more just washing a bit of water through, like you did to extract the humic acid. To make our compost tea, we need it to be an aerobic atmosphere. So you're going to need some kind of a pump, and you're going to need to bubble water through the barrel. Now, this might be out of reach for you, but you might begin to think creatively about how you might solve that problem. You've got to be able to bubble water continuously through your system for 24 hours or 48 hours, depending on the temperature. If it's warmer, it happens more quickly. Life happens more quickly. So this might be the challenge, it might be the limiting factor, but all we need is a small pump that can then push air to the bottom of the tank, and that bubble up. So factors that make a good compost tea. Number one, we need aerobic, and it is full of the organisms and the nutrient for the organisms. The next most important thing is that the tank is fully aerated. So actually what we're going to do is make like a tea bag. Imagine you had your muslin cloth or old shirt or something, that we make a bag of the compost, and we suspend that in the tank with the water bubbler, with the air being pushed in from a little pump hose. We have bubbled air, and that bubble air is going to interact with that compost continuously, and as the air bubbles up through it, it's going to dislodge the bacteria, the toads, the protozoa that are stuck together with that glue, and so that they become free and can circulate within the tank. Sorry, I'm receiving a phone call. I wonder what that is. Just one second, sorry. I just need to. Talking to myself, so sorry about this. Family responsibilities.
Steve,
Yes.
we could take a
Yeah, it's time for a
break.
little break, isn't it? Yes, thank
Yeah,
you.
let's take a break and then we can be back at 20 past for the next session because now it's
Yeah.
7 past.
Okay, thank you, Gerald.
All right. Okay, guys, see you in 12 minutes. And feel free to put your questions or contributions in the chat. We are here to, answer or support. Okay, see you then.
Okay.
Hi, everyone. Hope everyone is back.
Thank
You
you,
could
Gerald.
do a thumbs up if you're on. Steve,
Yes.
Simon had a question, a very important question.
Okay.
He wanted to know what exactly is a pest.
It's a good question. There's no such thing. Well, I didn't say that exactly, but we've come to regard things as pests because they're competing with us for our resources, eating our crops. You know, stem borers and armyworms and aphids and there's things that attack our crops. What I'm saying though is that actually they only attack the weak crops. They attack unhealthy plants are vulnerable to pest attack. And if we have healthy plants, we shouldn't have pests. We shouldn't have those organisms that feel like they're our enemy. We want to kill them. Would anyone else like to add to that?
Oh, thanks, Steve. Yeah, usually what I tell people is, first of all, in an ecosystem environment, a pest is simply a very important element, probably in a wrong place or in the wrong placement, like at the wrong time. Sometimes I tell people, even us ourselves, if we are wrongly placed and we haven't done proper planning, we will end up probably getting regarded as pests. So the reality is there is nothing like a permanently destructive element. It's a case of either placement or wrong planning. And I think as we go on, we'll be seeing more and more of this. Thanks, Steve.
Okay. Okay, so we were talking about compost teas, and we're going to be making compost teas. We're going to be showing you our process. So I'm going to stop on that. I felt like I was getting into a lot of detail, and at this stage of the course, I want to still be thinking about these wider patterns. And what we've been thinking a lot about is strategies to maximize yields by observing nature, understanding the organisms, the conditions they need, but also thinking about how we as people, as much as we're thinking about the biology and the soil, we're also thinking about our communities and society, how we work together.
Hello.
Matt?
Tracy, where is it?
We're okay? Yeah. So this is a little bit, it's going off on following a slightly different line of thinking, but this is a talk, grow your own neighborhood. Let's just think about strategies that we might do to build communities and links between people. And a few years ago, I did some work with an organization called Squash Nutrition. They're based in Liverpool. Liverpool's a big city. It used to be one of the most powerful and rich and important cities in the world in about 1860. More recently, it's had quite hard times. There's quite a lot of poverty there and need for sort of social regeneration. And I'm going to just sort of touch on a few stories around on that theme. And this was a talk that was done for them. I'll just let some people still arriving. Okay. Squash Nutrition, or an arts and health initiative, art and health. They had an idea as a social enterprise to engage with the community and they brought together people who were nutritionalists, gardeners, cooks, artists, beekeepers, workers, writers. Think about this in Nachi Valley or in a community setting. Think about perhaps bringing together a range of skills that could help participate in creating accessible, creative, interactive ways to bring people into thinking about improving their well-being. So permaculture is about how we meet our needs. It's about well-being in the natural world, in our community, and in ourselves. So let's think about how we might do that. So Squash have done all sorts of work over the years, public health events, outreach events, telling people about the positive benefits of, of good nutrition, exercise, of being sociable, tackling long-term health issues and well-being issues. They thought of ways to engage with the people. They thought growing food, cooking food, everybody likes to eat food. So if we can just build people's interest into it. So a real problem in the West is people eat processed food, too much processed food, and it's kind of cheap, but it's bad for you. So Squash are interested in engaging people with growing food, eating and preparing food, and also in bees and beekeeping, and using art and different ways of activities to energize the community. Refined how to have fun and engage with people, get people out and operating together. They created lots of resources to help achieve that, and including urban food projects. They had a film festival. So think about, look, what I love about this organization is that they've used so many different approaches to engage and connect with people. From having films to art, drawing, making, cooking, sharing. Some people are interested, want to know about beekeeping. Some people want to know about fruit trees. Can we use art and communication skills to join people together? This is a cinema in a polytunnel. This is a garden in the back of a truck. This is like making use of community spaces, available community spaces to have fun and bring people together. What can we achieve by being creative? The part of the project that I was engaged in was one they called Village Farm Orchard. And the idea was we were going to start small forest gardens, little food forests, polyculture systems that might live for several years or many years in and amongst people's houses, to grow them on land that was maybe publicly owned, public spaces, not private spaces. If a fruit tree is growing on a land that no one owns, who owns the fruit? Whoever picks it. We're interested in creating assets that made the community come together and feel like that they had shared wealth, if you like. Hi there. Hi, I'm in a Zoom call, so I shall carry on. Yeah, so I had a very interesting couple of years working with community groups. Here's a map of what they call Stockbridge Village, high density social housing project in an urban setting, but actually with lots of green spaces on the edges and traffic circles, and actually spaces which I often see are cultivated in Uganda. But in the UK, very much not. It's quite a radical idea to do that. The project tries to use art and observations from the community to help them see and value what they had around them. We always want to, there's the tendency is to always wish that we had something from outside, something from far away to meet our needs, rather than realizing permaculture is, well, can we generate that locally from what we have already? And to be able to do that, we need to value what we have, what's there. So to grow your own community, you need to buy local. You need to interact with people locally. I love the image of this hand that becomes a tree with subdivisions that might connect people together. So let's think about how we might use permaculture to connect people together. How do we make our communities stronger? How do we make people feel that they're part of a team? How do we make people feel they're part of a collective effort, a long-term effort towards achieving these goals of catching and storing energy and building yields which then nourish the community. This is what we're trying to do as permaculture designers. So this next picture is of a monoculture. This is a field, and what you're seeing there is plastic film which is being put on the soil to protect it from it, to make it a bit warmer and a little bit less wet, so that we can have successional plantings of the same plant. This is a 300-acre field that's growing one type of vegetable, 2 varieties of one type of vegetable. This is a true monoculture. The only way you can maintain monocultures is by using lots of pesticides and lots of fertilizers, because you're creating the right conditions for pests and you're depleting your soil because you're returning nothing back. This is the absolute opposite of permaculture. This is what we're trying to steer you away from. Don't do this. Don't try and just have a huge area of one plant. It's going to come into all sorts of trouble very quickly. I like this little graphic. It said, try organic food, or as our grandparents called it, food. We make this big song and dance in the modern day about organic food and food quality. And I've already told you that good quality food comes from good quality soil. Well, before we damaged our soils, before we killed the life in our soils, all of our food was organic and all of our food was healthy. A lot of what you have there in Africa is still organic and good quality food. But the more you damage the soils, the more you till and plow and use pesticides and fertilizers, you will deplete the soil biota, and you'll be there spending a premium to get food that's actually nutritious. Community gardens. I like community gardens. I like these spaces that bring us together and in a sort of common endeavor. This is in New York City. This is on Manhattan Island. In previous decades, communities have been very proactive about rehabilitating derelict sites within the city where houses fall down, or bare bits of land that were just maybe spoiled urban spaces, were carefully cultivated to make into community gardens, spaces where people can come together to grow food and also to recreate and interact with each other. From there, if we can build community, we can have stronger links between people and the potentials to create so much more and achieve so much more by building teams. So here, very simple, food waste composting. Compost strategy is at the heart of the garden. Waste cycling is at the heart of community. And from this, catching and storing energy, returning it to the soil, we can build yields. This is how we do it. This is what it looks like in New York City. What does it look like in your place? So in a big city like this, just how valuable are these green spaces to birds and insects, to wildlife, to people, air quality? Think about the multiple yields from such a space. The community bonding, the community interaction, all of this, what can come from a community garden, aside from the food, aside from the soil building. As I say, if they're doing it in New York City, understand how you take the same ideas and translate them to suit your climate, your needs, and using the resources that you have. This is another one this is Long Island City in the neighborhood of Queens. So this is also greater New York City. And what you're looking at there is an intensive vegetable growing operation on the roof of a building that is 6 floors up. Now, roofs can be problematic. They're windy. You haven't got much soil depth. You've got to think about where your water's coming from. But look at this for creative use of available spaces. Look how we have a polyculture garden, lots and lots of variation, different conditions, creating lots of niches for different people as well. Think how many jobs this kind of farm creates. Just a couple of guys sitting on big machines driving up and down. It doesn't create community, it destroys community. This kind of garden builds community, it builds soil, it recycles waste, it starts to become part of the sort of cultural ecosystem. This is what we want to do. This is good design. This is an abandoned elevated railway that's become a walkway, and then again the edges of it have been allowed to regenerate and to cultivate to become either productive for nature, productive for people, creating a quality space for people. Look how in permaculture we're very good at utilizing otherwise unused edges, surfaces, roofs, old roadways. Think about that idea about succession that we kept talking about, is we can creep in and spot these opportunities. What can we do? Can we engineer circumstances that bring people together in ways in which we create more social cohesion and we create almost inviting people into a common vision? We can use community gardens, and community gardens can look like anything. They just need to fulfill the function, and you use what isn't being used. This is 2009. Here's a group of people, they're actually on a permaculture course. We've identified an underused piece of ground, and we are designing and planting a food forest on it. We've been studying that as part of our course. We've generated a budget because we've had some course fees for people on that course. And with that, we bought plants, and there's our garden that we've planted. There it is some months later, becoming established. Fruiting trees, shrubs, ground layer herbs, working together as a whole to create a system that looks after itself, feeds every component within the system, and as it grows and develops, creates yields for us, people, the fruits and herbs and berries and everything else that come from it. This is another rooftop. This is a community centre in Reading. This is actually, this building here on the left is 39 London Street, Reading. And the reason why the training organisation, we're called Sector 39 or S39, is because a part of my permaculture education and part of my growing up was to be involved in the conceiving and establishing of this roof garden, turning this leaky, ugly rooftop in a city centre into something that has 170 species of plants, all of which are edible, medicinal, herbal, multiple use. And this whole system is organic, and it runs on its own, the nutrients that it cycles within it. This meets all of our permaculture criteria. And at the same time, it creates an environment for people. This is an education centre. So actually what you're looking at is a classroom. It's a place where people can come together, talk and learn, interact with each other, but it's shaded, and the conditions are modified by the presence of those plants. So think how permaculture landscapes could fulfill many functions. This is feeding insects, this is feeding birds, this is building soil, and this is feeding people. But it's also a place of recreation, of interaction, of learning, a complex environment. It's built out of the locally available resources that have been combined together strategically to create something that has a life of its own. This is permaculture. Harry, this picture here is actually an organization in this was 2010 that had a factory that made compost from organic waste from the town of Newtown, and actually, which is a town in Wales, and neighbouring towns. So what you're looking at here, let's just go back a bit, is this big shed here is a big factory. And if we go inside that shed, this is what it looks like. Oh, there we can see it from behind as well, like a big just industrial building, pretty ugly. And there's a dead piece of ground behind it. What they're doing in that building is they're joining together carbon and nitrogen in a way which will create a usable, pathogen-free, seed-free compost. This is how they do it. This pile of waste here, of material here, is actually food waste. Each one of those is in a biodegradable bag, a bag made out of cellulose, and in there is high nitrogen food waste, vegetable peels, cooked food, animal bones, you name it, all that stuff. And what's going to happen to it is they're also going to bring all of the branches and trees that have been cut from overhanging power lines and road edges. We're not going to burn that. We don't want to return that carbon to the atmosphere really quickly. What we want to do is use that carbon to make compost. We get carbon and nitrogen balance right, then we get a really good compost. So that's what happens here is this green machine here, it says Eco Green on it. It's a macerator. I think there's a conveyor belt that lowers down and you put material into there. So you throw in your food waste and it gets chewed up into small particles and spat out into this big hopper. And the same with any branches, any vegetation, waste wood materials that come from the town. That's also chopped up, macerated, chopped up into small pieces and sprayed into this hopper and mixed with the food waste. So we've got something that's quite high in carbon with something that's quite high in nitrogen. And it's left in this hopper for 48 hours and the temperature will rise to 70 degrees centigrade. That temperature when it's too hot to keep your hand in the compost. After 48 hours, we can be sure any pathogen organisms, disease-spreading organisms, any seeds that are in that compost will have been neutralized. Now, to be able to sell this commercially, we had to take a sample of each batch, send that to the laboratory to be tested, and then that gets a kite mark, a pass 100. The compost isn't quite ready. We know then that it's disease-free, but it hasn't the biology, the bacteria, the nematodes, the protozoa, the amoebas, and everything else haven't had a chance to break it all down yet. All we've had is the quick moving thermophilic bacteria, the ones that create all that heat. They come in first, and now we're going down. The compost is going to cool down, and we move it using a tractor to the other side of the factory, where actually you can just see there's a series of 1, 2, 3, 4, 5 bays, and each week the end bay is emptied out. There's a picture here, not quite, and then they're each moved on. So turn. By the time it's been turned 5 times, the compost is ready. The process takes 5 or 6 weeks. So this is a industrial size compost making factory. And what it's done is they've identified the waste streams from the town, food waste and this high carbon kind of woody waste. It's not really good enough for fuel. It's not good enough really for construction. So instead we're going to use it in composting. So we've done the analysis. We've asked ourselves the question, what's available locally? How do we combine them together to produce high quality compost? Okay, now, we were shown this backyard. I came with a group of permaculture students in 2010, and we suggested to the organization, they wanted to know what to do with their backyard. They wanted to start a garden, and they'd employed a gardener to do it, but it hadn't really worked. Cost too much money. The productivity wasn't high enough to be worth what there was cost spending, and they're only really cultivating a small part of the garden. So we came along with a kind of different approach. We thought, well, as permaculture designers, we need to capture, store the energy of the community. We need to build teams, energize the local community to see a vision that this space could be a wonderful garden. And there's two real ingredients we need to make a garden. One is we need to build the fertility from compost. Well, it's a compost factory. And we're going to need water. And oh, look, there's a big metal building. We can catch the water off the roof, store it in tanks, gravity flow it into the garden when we need it. We can, if we've got compost and we've got water, even this soil looks dead and compacted, we can bring it back to life with the life that's in the compost. So there's our team of permaculture designers. Sat by a little water trapment area, so there's the first bit of wildlife enhancement. And here we are considering the options for the garden. And from that, the students began to make plans for raised beds. They thought about the size of the beds, the placement of the beds, the function of the beds. We thought about access path. This yellow here is a pathway. We thought about a space for people. We thought about an enhanced area for plants. And we started to think about space for short-term, medium-term, and long-term growing plans. So usually your first plans are fairly sketchy or visualizations, and then we add layers of detail. So here in this garden, we wanted to bring together our permaculture principles. We wanted long-term trees. We wanted tree crops, fruits and vines and climbers and shrubs and berries. And we also wanted lots of raised beds for growing annual veg. We also thought about the sequence of things that we might do. So what would we do first? Week 1, week 2, week 3, week 4. So we're not going to achieve all of the goals of our project. It's very easy to draw a nice picture like that of what we would like it to look like. How are we going to get there? Could we run some courses? Could we offer training to local residents in the skills that they might need to help build the garden, or skills that might help them appreciate the garden, to see the potentials of it? So we try to use permaculture design as a visioning and team building tool. We brought successive courses there, and as we develop the garden, each element that we put in the garden, something we can study, something we can learn from, something we can use an example to recruit more volunteers. Here's how working with a student group and learning by studying the elements of the garden that we're building. We're maximizing the yield, because the knowledge yield, that learning, if you do the same thing every year and repeat it, you're not really learning much. If you push yourself, let's try making raised beds, let's try different composts, let's try compost teas, let's try different varieties. As we learn, we might have some successes, we might have some failures, but those in themselves teach us, and it gives us more knowledge then to use, to share with our communities. So think about how everything is a resource. Here, Emma is doing some pruning on fruit trees. And again, it becomes an educational thing. There's something to discuss with students and learn from. These are pickles and ferments, ways of catching and storing the yields from the land. And then here's the garden. Only 2 years in, we brought soil to life. We created a patchwork, complex sort of mixture of growing and plants, and in the process, we made many friends and built a team. Now, interesting, this is part of a story, was this garden came about through a kind of mutually beneficial relationship. It was actually an ex-student of Sector 39, was working at the compost factory. invited us there to come study it. The idea to build this garden came from that. The building of this garden inspired the Come Harry organisation to go away and write a funding bid, for which they were successful as a funding stream in the UK. It comes from the National Lottery. It's gambling, basically. But they fund sort of community ventures. And we were lucky to get some funding to run a 3-year project, which we called Get Growing. And that only really came about from the lessons learned and demonstrated from building our first garden. So it turned out, the garden was small, it was in the wrong place, and we didn't own the land, and we had to take it down. But in the process of building it, we learned enough to start a whole new project and be able to move to a new place. This is the sixth form college. This is a further education college. It's where lots of 16, 17, 18-year-olds maybe go and study mechanics and carpentry and hairdressing and food skills and so forth. And this little patch of land here, 3 acres with a couple of buildings, belonged to the college, but they didn't know what to do with it. They didn't have a clear plan, and they didn't want the responsibility of managing the land. And this was just about the time that we were successful with this grant, and then that opportunity came about to start a permaculture and horticulture demonstration and training centre next door to the college. So again, think about mutually beneficial relationships. Is we could grow food and herbs and produce that might be useful for the college. There's a housing association here. We could provide activities and training, perhaps some of the local residents, and we could build a garden that's productive and good for nature and something that we can learn from, and hopefully something that becomes an asset to the wider community. Now, this is what we've done in very specific examples in the UK. But you'll have similar opportunities where you are. They'll look different, and there might be a different combination of opportunities, but for sure they're there. There's always unutilized land. There's always unutilized resources, compost and water, and there's always unutilized people with a bit of spare time, and if you can create the right soil biology, you can bring any kind of soil back to life, remember? So knowing that, we can have confidence. We brought life back to this yard. There it is. We brought life back to that yard. There was no soil there. It was just they've been parking lorries and turning cars around there for years. It was rock solid. As we developed the garden, as we brought the life back into the soil, it became incredibly productive. In fact, it was really amazing how quickly that happened. So it's about getting it right, and the system builds on itself. So we started off our new horticulture centre with a course. We did some training, and then we invited our trainees to start designing the garden and using the things that we discussed on the training. Here's some of our early participants. We started, because we had a plan, we had a design, we could then engage the volunteers in the process of building the systems that are going to catch and store energy. We trap water, convert compost into soil microbes. We built our wonderful hugel beds, which I showed you last week. Catch and store energy, using the available resources to create intensive growing systems. And growing systems that actually, once established, need very little maintenance. We've got fantastic yield from this hugel system. Here's again, working with students, establishing our food forest. So we're studying, learning, gaining practical skills, and building a garden that benefits the community at the same time. We call that stacking functions. So begin to think about how the insights, the ideas I'm giving you might fit together. juggle them around and find the fit for the circumstance that you find yourself in. We touched on grafting. This is a course. We brought in an expert, someone with some specialist knowledge, and they're teaching us how to do fruit tree grafting. And there's different techniques, there's different approaches for different types of plants. These are things you can quickly learn. When you know them, you can repeat them, and when you repeat them, you get better at them. If you can create your own trees, you can then create your own orchards. And once you've started this process off, you then have the materials you need to keep building and keep growing. As we developed our demonstration and training center, we could build relationships to other teachers and trainers. We could develop the range of, this is a plant ID workshop, and we could offer different trainings, which then might create ways to connect with different segments, different people within our surrounding community. Willow weaving. Willow weaving in the community garden as it develops. So as the space increases in value, then we can use it in different ways. And by inviting community members into your space, they then begin to learn about it and become inspired by it. Inspired by the garden, we did some outreach into the parts of the community and help start off little pockets of regeneration. This is back to the Liverpool project, and in a very urban setting, high density residential housing, lots of people in a small space, but still with green areas and edges where we could squeeze in a polytunnel. We could look into the local waste stream, and we could access compost from food waste, wood chip from overhanging, clearing overhanging wires. We can combine these materials again to build. We're growing the plants that will be part of our food forest systems. We're growing plants that are good at building soil. We're growing plants that are good at feeding the beneficial insects. Multiplying them in our dedicated nursery beds and protected growing areas. And as we multiply the plants, we've then got them to plant out and then take out across the community, engage with people close to their homes, where they are, give them some introductory skills. This is how permaculture works. It can be very difficult to do community engagement. If you just go and knock on doors, people don't want to talk to you. What we found is there's always a way in. This lady here on the left, she was the kind of community matriarch, and she came and had a word with us, and she liked the idea of a planting a community garden, and because she liked the idea, everyone else on the street came and participated. So you've got to find your way in. There's a lot of skills to working with community and working with people, but if we can unlock that energy of people, then we can achieve so much. So here's us look, establishing productive food plants in little orchard groups, plant guilds, here on the edge of a bus terminal. So can we bring beauty? Can we bring diversity? Can we bring productivity into the cities, into community areas? And can we do that in a way in which we make new friends, in which we make new connections, a way in which we add value to the produce that we're making by fermenting it, making it into jams and preserves, cooking it into different meals, teaching people the skills about beekeeping and plant rearing, creating community events where people can share their new knowledge. To me, all of this is permaculture design. So Squash, this organization, Squash Nutrition, was so good at using art to engage community, to make it attractive, and cooking, just simple processes. I love this poster. You can't buy happiness, but you can buy local. It's kind of the same thing. If we buy local, we create a strong local economy. We can have our own local produce. We can be generous with it. We can use it to build relationships, to support our own needs, but also support community needs. I've punctuated my life with doing intensive 2-week permaculture design courses. Here's a poster from one from back a few years now, 10 years ago now. But it's a great way to meet people. It's been a great way to build a strong social network, a great way to grow skills, and it's taken us to many different locations. So here we are working with a local landowner he lives up high in the hills, this guy, and we're introducing, here we go, here's our fruit trees. We're thinking about a succession of plants that could add yields and add productivity to this system. Another community garden, another teaching endeavor, another group of people brought together around common themes. Derelict places, on the urban edges. If we can build teams around it, we can create a common vision. These places can be converted into productive spaces. Look, raised beds, fed with compost from local materials, strategic placement developments. There we go. Little insights into seeing how the things we've been talking about in theory in the first half of lecture, and there's some of those things in practice in the field. Mainly here in Wales. We have many examples to show from Africa too. But I want you to see how whatever you do is going to look different. But actually the processes and the functions are the same. So to think how to copy that and bring that into your own design. I'm very open to questions. Comments and feedback. Otherwise, I'm going to show a few more slides.
Steve?
Yep.
Sorry, there is Udo. He was requesting to record the session, but I informed him that the session is recorded and is available on YouTube, so he'll be able to replay it. And
thank
just
you,
to let all the others also know.
That is very true, and thank you for making that clear. Yes, so we are recording this, and yes, as saying, it's also being streamed live on YouTube, and we will post a link to that as well. So, and you'll be able. This is lecture 6, so the previous 5 are already there. So, and you're very welcome to access that. And also on our website, I've also made it so that these slideshows are available, and you can download them, so you can revise them in your own teaching. So I call this Sector 39 an invitation for collaboration. So firstly to say, you're really welcome. Welcome to be on our PDC. Welcome to be on this mission, and to share our mission and share our goal. And I hope that you'll stay with us for the long term. I hope that you will help spread the network where you are in your community, because we believe strongly that permaculture is for everyone, and that we could all find these ideas useful. We all eat food, we all drink water, we all breathe air. We're all part of this sort of nutrient cycle. So let's take an active role in that. So the mission statement of Sector 39, named after 39 London Street, Reading, where you saw that roof garden. Our mission statement is to accelerate permaculture learning through education. And we want to develop working examples of permaculture projects in different contexts. So we're not preaching to you with just ideas. We're showing you, here's the project, here's the application, here's the example. These are the tools, the design tools that we use to create that. So with that, the first two steps of our mission statement, we hope to bring permaculture into new areas. And by that, we mean through you to your home, to your community. We could all learn from each other, because every time we do permaculture, it's kind of unique. Something new happens. So there we go. Welcome to Sector 39. This is a lifelong journey. I hope to see you right the way through. Yeah, we're named after 39 London Street. Here it is. There's the original roof. Here's the garden being really well established. There's a community group of people up there meeting. You're seeing there's bamboo plants, there's loquats, there's medicinal herbs, there's 170 species of plants, something like that. And think what that does to storing rainwater, humidifying the air, habitat for insects and birds. I lived for a long time in the Welsh Mountains. I still do, but in a different part. In 1995, we managed to access a piece of land in this highly grazed, highly kind of degraded, over-farmed area. And you can clearly see, this satellite picture is after about 10 or 15 years of living there. You can see what we've done. You can see the land, our 3 fields and houses, because we've put the trees back. We still maintain open pasture. We've got water. We've got wetland, but we've come in from the edges. We've created wind shelter. We've created wildlife corridors. We've created habitat, productivity. Here's our intensive Zone 3 vegetable garden, surrounded by wind protecting trees and fruit trees, and so forth. And there's the buildings, old stone, 200-year-old stone buildings, which we slowly converted to become more energy efficient. We built a community using permaculture, and we called it Chicken Shack. I lived there for 13, 14 years of my life before moving on to now a new cooperative. I've been applying these permaculture principles wherever I've lived since the day I came across permaculture. So, yeah, a little bit of history. Permaculture Wales, we were doing project management from 2005. Started teaching permaculture about 2006. After about 10 years of being a practitioner. And in 2014, we registered a company. And in 2016, we were invited to, 2014, we were invited to Uganda. In 2016, we started teaching there. And in 2021, we won the International Permaculture Prize for our teaching work. So it's been a journey, and one that I think we're just getting going on. We're very much a team, we're a family. Since we've been doing work in Uganda, I like this. Oops. I like this picture here. The 3 of us at the back are from Wales, the team Wales, and the guys at the front from Uganda and Kenya. This is from 2018. This was us doing some work in a place called Bidi Bidi in West Nile. And here's the wider Sector 39 family. Look, the people that we work with that keep coming back and wanting to involve in our projects are the people who trained on the courses. Permaculture connects you to other people. Shared values, shared interests, shared project work, shared ambitions. I hope that we can just grow and become a stronger family. And as I say, we're open for collaboration. We're open for partnership, friendship, mutually beneficial relationships. Permaculture is global. Here is a First Nation poet and speaker from native from America. Regenerative agriculture is not only about regenerating soils, it's about healing relationships, healing history, healing the people who still languish in the shadows of the legacies of colonization. So there's a thought, permaculture as a healing process. Think of the damage that's been caused by warfare and greed, slavery and colonialism and racism and everything else. What's our healing process? Permaculture makes us realize that we, on certain levels, we're all the same. We all have things in common. Breathing air, drinking water, eating food, part of nutrient cycles, reliant on solar energy translated through soil into food. These are the things that we all have in common. These are the undeniable truths. Organic matter decays to compost. Plants grow towards the light. Water flows downhill. That's true whether you're a Muslim or a Christian, a Sunni or Shia, Protestant or Catholic, man or woman, black or white. Those are universally true. And those are the things that bring us together. And I think that that's what we have to hold in our hearts. And when we understand permaculture is global, but we apply it locally. So here's our Paramaithi Cymru permaculture Wales. We're applying it through our homes, our communities, locally, but we're conscious of this global presence, that we're part of a global family of permaculture. You're part of that too. So our current work has been to build on almost a sort of random hodgepodge of courses and training and friendships and connections that we've made, and to try and bring that into some shape. So I live in Wales, I live in the Welsh borders, I have a friendship with a local farm, it's called Treflac Farm. I ran a course there a couple of years ago. We came up with some design ideas to build a garden using volunteers that fits the farm, that helps suit the other outputs and activities on the farm. There's also a long-term soil building experiment. This is our garden. It's our mandala garden. This is from a couple of years ago. It's settling in nicely now. And this is where we're going to be doing our biochar experiments, our compost experiments, our compost tea experiments. It's all going to be going on here. We've got green manures going on here. We're trying out a wide range of different ideas, and we're going to demonstrate them to you. And and we're going to encourage you to do the same. So here we are, working locally, building relationships with the local farm to do permaculture. We're growing food. We've got a dig, no dig system. We're testing out some ideas. We're experimenting with biochar. And I'm going to get into that later on because it's a big part of our story. It's a big part of how we get carbon in the soil, how we add more air into the soil, how we create passageways for water infiltration, how we build the long-term fertility of our soil by creating better habitat for microbes. Certain ways in which techniques we can use to turn low-value waste materials into a stable form of charcoal, which when introduced to the soil will stay there for long periods of time. And by that I mean thousands of years. It's our biochar that we made from waste material on the farm, and we've started experimenting with that. We'll be talking about that later on. I've touched on our bricks testing. There it is. There's us testing the sap of a cabbage plant, and we're slowly learning the subtleties of plant fertility, understanding how plants are living and changing and modifying the conditions as the day goes on. When it's rained and the plant takes up more water, the bricks value, the density of the sap of the plant goes down. As the day heats up and the humidity rises, the sap then becomes more dense and the bricks value goes up. start to tune into these subtleties, realizing how our plants are living and breathing and responding to the environment around you. Here's, again, adding a drop of the sap of the plant onto the lens. And here, working with a child, a local friend, part of our learning, part of our experience, socialization. The school's given us a nice classroom to work in, an old converted shed. And off we go. That's part one. Part of that is the UK base of the Sector 39 Permaculture Academy. We also have a training base in Kenya, Permo Africa. People that we met through our first early PDCs. Here's Paul Agola back in 2016, 2017. And Helen Anyu, as one of the founders of UPO, another organization within our family. Here's Paul working in the field with us a few years ago. And I think, is that Gerald there? I can't see the back of the head. But look, here we are making really nice raised beds with mulch, beds that are going to catch and store rainwater and give a chance to build long-term soil fertility. Here's the founding of Permo Africa as a water catchment feature. Paul was able to communicate his ambitions to his surrounding community, and it allowed him to design and plan and build his demonstration and training center and build a partnership with other organizations so he could demonstrate, educate, replicate, and teach permaculture design. So congratulations to Paul, who's created a classroom, demonstration site, built it up and maintained it now for, I don't know, we must have been into 5 years. Paul tells me in the last 3 years, he has trained 3,600 people in permaculture. There's 40 people at Permo Africa right now studying this same course. So if he can do this, what can you do? How can we inspire each other? How can we support each other? Can we understand that, again, ideas that were communicated and learned at Permo Africa and then replicated in other locations across the community? This is a satellite project. They're growing Sakuma Wiki in raised beds made out of locally available materials. How valuable are these green spaces? Because they bring community together, they provide produce, and they're building soil. You look after these beds, they become more productive each year. We don't grow them. We don't dig them. We don't turn them. We don't stand on them. We just keep feeding them with compost, rotating the crops around, and they become more and more fertile. Think how permaculture can bring together different generations, how we can build and add value. Yeah. So this is another project in Wales, local project in Wales, bringing back biodiversity, expanding tree cover, creating more habitat, more space for wildlife, interacting with the community, adding value, creating niches where people can come together. This is another farm we've had links with, come and talk to us, exploring ideas how they can bring diversity back to their farm. We have our dear friends in Rwanda who are the driving force behind starting the Rwandan women's permaculture movement, where they've worked at a local high school to design and build a community garden that harvests the rainfall from the buildings and then converts that into high quality food, shade, modify the environment, feed the students, inspire them to see other possibilities. There's fantastic work going on across Teso district. I've mentioned Eastern Uganda permaculture. There's a Teso advanced permaculture, and the amazing work they've been doing there with the mud stoves, the Lorena stoves, fuel efficient stoves that don't produce smoke, reduce the amount of energy out of the amount of wood you're using by up to 80%. Here's Ali Tabandeki, another member of our team, who's also teaching. Look, this was a slideshow we put together a couple of years ago, a little while ago, but to see how permaculture manifests itself. We share common values. With those common values, we can build long-term goals. And if we can agree about our values and our long-term goals, then it's simply a matter of breaking those goals down into stepping stones, into strategies, into activities, understanding the process that we need to go through to achieve our long-term goals. We have to be able to come together as a group and agree on those core values and informed by those values, those long-term goals. If we can do that, there's nothing we can't achieve. We can bring people together to make them understand and feel that they're part of a team, that we're not in competition. We share the same long-term objectives. There we go. We've got a few minutes for questions and feedback. Any comments or anything? Super interested to hear any thoughts that you're having. Anything you'd like to share?
Thanks, Steve. Woodrow had a question about whether we have any links in Nigeria, or whether we have any links in Nigeria. And then, Steve.
So I'll keep my camera on so you know that I am here. Yeah.
Yeah. Udo had a question whether we had any practitioners or links in Nigeria.
We will find out for you.
Yeah.
And we can do a search. I'm telling you, yes. I don't know the links, but they will be there. Permaculture is in every country. There will be pioneers. There will be people starting off. We'll try and help them find them for you.
Okay. And Ali has his hand up. Go on, Ali, unmute yourself.
Thank you so much, everyone, for this wonderful sixth episode of this permaculture design course. Actually, it is very exciting. It's very insightful in a sense that it is really eye-opening and then also reorienting some of us. And I really appreciate this. And for the new pioneers, Sector 39 is a body that embodies all of us, not only in your particular country, not even in your community, but it's a network that helps to build the cohesion that we all seem to like. And I'm glad that Nicholas Ora, I'm also with him in one of the programs as well. I'm glad that he's also watching and is attending. And I would like also to thank Caroline Olang, Hilda Warumbe. I do believe that she received her vetiver a week ago. And everyone who's been attending to this is really super. Jared, thank you so much for moderating and ensure that everything and communications, everything goes well. Steve, thanks for leading this. We are behind you. Thank you so much.
Thanks for that, Ali. Very welcome comments. Thank you. And yeah, you've inspired us as well so much with your work and your continuing work. And as we move later into the course, I'd love to have, for you to share and talk about some of what you're doing at Butambala. And I'm sorry I didn't say more about it earlier, but I just wanted to name check you at least.
Okay, thank you so much. Tebandike Ali is my name. Some of you that don't know me, I'm the lead designer for Butambala Permaculture Learning Center, where we are trying to help the vulnerable small-scale communities to transition from conventional agriculture to regenerative agriculture by use of permaculture approach. So the whole idea here is that people in Butambala were used to, using plastic chemicals to fertilize their soils. They used poor farming methods to ensure that they produce yields, which was busy deteriorating because of the climate change. And it's my native village. It's where I was born, but my hometown is in Natete, where we are doing the regreening project, and which is known as Natete Green Youth Organization. So that was my first project after doing my PDC. It was one of my first projects to do for urban settlers. So it is the urban project for permaculture that I am doing as well. So we have now produced more than 200 people that are now busy spreading the word, as well as helping people to grow food in urban centers of Natete and beyond. So at Butambala, what we do village savings and loans association or micro lending. You have mentioned about that. We are also training PDCs at the center. And then we also doing poultry, that is chicken coop, where we are trying to conserve the native chickens of Uganda. So we are also doing that. Then we are also doing worm farming. We are doing vegetable growing, food forest systems, and then also water harvesting systems, and also making of our own pesticides and fertilizers. We are also practicing IPM. In other words, we are doing the agroecology by the help of permaculture approach, because we do believe that once we involve the communities in our work, we are building wide and wide. At the same time, we continue to inspire more people. We also work with some schools where we have children as well that are also participating into our programs. So I really welcome for the newbies, I really welcome you on this journey. Don't stop. Permaculture, we need it more than ever before if we are to create the world that is beautiful to be in, or a better place for us to live in. Permaculture is the solution. However much we talk about climate crisis or we talk about climate change, but if we don't put these things into practicals of our daily life, then permaculture should be the answer. Thank you so much, Steve, for bringing me on the spotlight.
Thank you, Ali. Great words. Okay, we're into our final moments, really. So any other just comments?
Oh, Simon has his hand up.
Yeah.
Go on, Simon, unmute.
Yes, I want to appreciate everybody for the contribution that he or she has made on this session. I'd wanted to add on the IPM pest management method on the cultural. One would do, I would have advised somebody to go on early planting. By so doing that, it enables him or her to do his or her work at a right time before the breeding range of the pests and the diseases. And then the other one is, I would have encouraged someone to practice mulching. Culturally, mulching creates a very good environment that prevents some of those pests and the diseases outbreak. And then thirdly, I would again focus on crop rotation. That also encourages us to break down the life cycle of those pests and those diseases, and eventually it will help us to control their life cycle and the break out. And then the other one is on deep plowing. One would do deep plowing in a sense that it helps to overturn on the on the eggs of those pests that would have been left breeding into the soil. And then the other one is early weeding. When weeds are properly maintained, the access of those pests and the diseases would not be as so threatening as compared to that person who has not maintained or who has not worked on his crops. That is what I wanted to supplement on the cultural methods of IPM. And then the other one is to focus on the pests. Pests would be categorized in two times, where one would say we have got the field pests and then we have got the storage pests. All of those can be both maintained by all the three systems of management, where we talked of the chemical, cultural, and then the mechanical methods of pest control. So when we go to the field pests, we have got some aphids. We have got some aphids that are sometimes hard to be identified by farmers when their crops are attacked by them. And then the other one is on the rodents. Rodents, this basically rats and others. When we talk of caterpillars, armyworm, mostly on armyworm, when the temperatures are too high, the rate at which it eats on a plant, it tends to be very high. So such a pest is very hard to identify at the field level. I would encourage that person to at least use some of the chemical, not chemical, to use the cultural pest control measures, where one would use a mixture of red paper and the onions, extract from onions, added with the 1 piece of a matchbox of blue soap. It will help on the control of armyworm, where he or she has to ferment it for 3 days, and then he applies it.
Wow. Thanks so much, Simon. That is so, a very good insight.
Yes.
I guess from that explanation, you have an agriculture background. Okay, that's brilliant. And also, I suppose are you coming from northern Uganda, Gulu?
I am in eastern Uganda.
Eastern Uganda. Okay. Yeah, it's brilliant to have you. And I think the connection has been so good. So we'll have a bigger session. And soon in our next sessions, we'll be having breakout rooms, and we'll be really, interested to have, deeper conversations. Yeah, I hope I didn't cut you short, did I?
No?
Oh, thank you. Okay. Thanks, everyone. Maybe just as one of the common saying, there is one of the common phrases we always use. If the flower is not doing well, let's not fix the flower. Instead, fix the environment, fix the soil, work on the soil. Most cases we are working bottom, the top bottom. So you're starting with the plant or with whatever you've grown. How about doing the normal approach, which is bottom up? Start with the soil, which is actually should be the starting point. Then when it comes to compost, I should say at least I've had an experience of both the tropical and the temperate. Most of us in the tropical, we should know that we have more than a gift, because the aerobic process there is really fast, and that's how you're able to quickly do it. That is more than a gift, it's more than gold in its own. In the temperate zones where it's cold and everything, the process is slow, and you find probably Steve will elaborate on this. It takes more than 4 or 5 times the time it takes. So I don't see any reason why any one of us would not be able to compost or to have very good soil. Unless anyone else has a comment or a question. Udo, do you have a question or a comment? I can see you're unmuting.
Yeah, I just want to make a contribution.
Oh, sure, please go on.
Okay, good evening, everyone. I'm speaking from the southern part of Nigeria, and I'm representing Farming Communities International. Okay, I got the invite for this meeting, but I think I missed the time because I joined late. So I'm just here to seek for collaboration, because I see from the mission statement that we have a lot in common with Sector 39 and my own organization. So on behalf of all the directors in Farming Communities International, we want to seek for a collaboration to see how we can have areas of mutual understanding and cooperation. So that is just the point I want to make. Thank you very much.
Thank you so much, Udo. And yes, that's our mission. That's what we always do. Yes, Steve says you could put the link to your organization in the chat. Yeah, and yes, we look forward to that. Back to you,
Okay.
Steve.
Okay, let me try if I can get that.
Yeah, okay, please. Back to you, Steve.
Okay, yeah, I'll try and create a little resource, a few links on the page for each week. And yeah, just saying it's great to connect with your network. And I know that you've got members all over, and I think this is a great way to collaborate and fully illustrates what we've been talking about. So thank you everyone for your attention. I hope that was a lot of stuff to think about. So that's the end of yields. We're going to move now to think about systems next week. And again, just get a little bit further into how all of these things link together, how it all works. So great. We'll look forward to that. And I thank you for your attention.
Thanks, Steve, and thanks everyone
See you next week.
See you next week.